Hi, Logic students. I wanted to show you how to solve a couple of exercises from section 7.2 in part 3 of the exercises. These are the most important exercises, the ones where you accomplish proofs of arguments. These exercises are not different from ones in section 7.1. You still have these valid arguments where you're given the premises and you're also given the conclusion. And what you have to show is that there is a path from the premises to the conclusion, where each step in the path is an application of one of the rules of inference that we have studied. The only difference in section 7.2 is that you have more rules. Remember that you can use, and actually you should use, all the rules. So both the ones that you learned in section 7.1, so modus ponens, modus tollens, disjunctive syllogism, and hypothetical syllogism, and the new one that you learned in section 7.2. So addition, constructive dilemma, simplification, and conjunction. Okay, so don't think that in 7.2 you can only use these, and in 7.1 you can only use these. In 7.2 you can put together the two sets. You can definitely use them both together, and you should, because otherwise, if you don't use them all, you won't be able to solve some of the exercises. So look over here. I chose number 7 in part 3 of section 7.2. This is a standard argument. I've already entered the 3 premises, and I have to produce T at some point. The way that you proceed is just as you did before. So you try to find opportunities to use the rules of inference, and you just scan the lines that you have and see what you can do. So immediately one thing that stands out is that lines 2 and 3 go well together in terms of modus tollens. You have a conditional, F then P, and then you have the negation of the consequent. So you can infer the negation of the antecedent, now F, by 2 and 3 modus tollens. And then this is something the author of our book likes. He presents you with one of the premises where the antecedent is not F or X, and the goal here is to get you to see that now that you have derived not F, you can easily create the string not F or X by addition. Remember, addition allows you to take a formula, put a wedge, and then tack on whatever you want. So not F entails not F or X by addition. Here you just cite one line, line 4. So line 4, addition gives you not F or X. And the reason why you want to create not F or X is that then you can do a modus ponens with line 1. So in line 6, you will infer the consequent of that conditional up there, P or T. It comes from 1 and 5 modus ponens. And now you're much closer to your goal. You wanted to prove T, so it's easy to see that you have P or T here, and up there in line 3 you have not P, so you can do a simple disjunctive syllogism and enter T. So T follows from lines 3 and 6. Sorry. 3 and 6, disjunctive syllogism. And you're done, because T was your goal. Okay, so you see how this works. You try to use the rules that apply, keeping in mind that now you have 8 rules. And there are several exercises where you have to do this little trick that we did in line 5. not F alone doesn't allow you to do much, but you notice that the antecedent of premise 1 is not F or X, and you know that you can easily infer not F or X from not F by addition. Okay, let me show you another exercise from that same section, which is actually very interesting to look at. Here it is, it's number 10. You see that the situation is the same as before. You have your premises here, you have the conclusion, you have to show that there's a path from the premises to the conclusion. But if you look at these formulae, you realize there's something strange. M does not occur anywhere in the premises. It's nowhere to be seen, right? This is something we found already. Remember we discussed it in chapter 6. There are arguments where the premises have a contradiction embedded in them. And when this happens, anything follows from those premises. When you have contradictory premises, any conclusion whatsoever follows. You could have M, you could have anything you please here, it would still follow. So any argument with a contradiction in the premises is a valid argument, and you can infer the conclusion, whatever that may be. So now that we know how to do proofs, you can see how that can be done. Once you expose the contradiction, it allows you to prove anything. So let's see how that goes. If you look at these three premises, there isn't really much that you can do with premises 1 and 2. They don't really go well together, and not even premise 3 seems to be the one that would allow you to proceed any further. Here's a rule of thumb. Whenever you see a conjunction, now you can break it apart by simplification. So D and F entails D by 3 simplification. Okay, this is always a good move. Whenever you see a conjunction by itself, break apart the conjunction and bring down the first element. And now you do that trick again that we talked about before. You have D, and you notice that up there, there's D or E as the antecedent of this conditional. So it'd be nice to be able to do modus ponens and bring down G and H. But with D alone, you cannot do it. However, you can easily produce D or E by line 4 addition. Now you can do a simple modus ponens with lines 1 and 5. D or E, then G and H, D or E, therefore G and H. This comes from line 1 and line 5, modus ponens. And then you want to do this again. You have this conjunction, so you can go ahead and do a simplification and get G by itself. Normally, well, let me put that justification first. 6 simplification. I was saying normally when you see a conjunction, when you can go from a slightly longer formula to a shorter one, when you see a conjunction you can break off a part, you want to do that because the shorter the formula are, the easier it is to work with them. Okay, so let's see where we are now. Well, we have we just derived G, and you can see that you can immediately use it with line number 2. You can do an easy modus ponens there. So line 8, you will do a modus ponens with 2 and 7 and get not D. 2, 7 modus ponens. Now the contradiction has come out. You see it? There's D here, and there's not D here. These are premises, the first 3 lines, are premises that if you unpack them a little bit, they spit out a contradiction, so to speak. You're going to end up with 2 formulae that contradict each other, D and not D. And now you can prove anything you want. If there's a contradiction, you can tack on anything you like. Take a D from line 4, you can make now you can do a simple disjunctive syllogism on lines 8 and 9 and get M by itself. So 8 and 9 disjunctive syllogism, and you have proved M. Okay, I hope this helps. It's interesting that when there's a contradiction in a set of premises, you can prove anything you want, and now you can see how you can accomplish it through this method. Let me know if you have any questions. Thanks.